All right, so chapter 15 is about freshwater. Chapter 16 is about saltwater. If you didn't figure that out, well, there you go. So the case study for this chapter was Louisiana, and it had talked about the coastal wetlands of Louisiana. And the thing about the Mississippi and every other major river, they've been dammed. And so remember, I was like, they're dammed for eternity. And then I was kidding. But seriously, all the major rivers on Earth are dammed, and so that'll tie into our energy unit. You know, we're going to be talking about running out of energy and what can we do. You know, hydropower is clean and renewable and all that stuff, but we can't exploit it anymore. It's already to the max, okay? The thing about the Mississippi, and you guys learned this when you were in world history, you talked about the beginning of civilization. Floodplains are great because you have all the silt that gets deposited during floods, and then you can grow food and everything's cool. Well, it turns out, like, during the dawn of civilization, literally during the dawn of civilization, people didn't have fancy houses and cars, and, like, they were more mobile. So they, you know, if an area flooded, it wouldn't be such a big deal, but now floodplains are really heavily populated. So we do everything we can to prevent floods. And you don't want to flood in your area. You don't want the water to come up and sweep your house away. So we can't really argue with that. But at the same time, there's been some negatives to it. What would generally happen with wetlands is that over time, at the mouth of the river, a mouth of a river is where the river meets the ocean or a larger body of water. At the mouth of the river, the sediment would get deposited and build the delta up. But when you dam a river, or you put levees around the river, then the sediment doesn't pile up, and so then your wetlands at the coast, they decrease by quite a bit. So I have some pictures for that. If you look here, in 1839, this is a coastal area of Louisiana, 1993, and then that's projected for 2020. So another reason that this land area in coastal Louisiana, as far as the wetland ecosystem that's present, another reason that's going to go down is because climate change. Sea level is going to rise, and between that and the sediment not getting deposited, you can see that a lot of that area is going to be submerged or not there. And here you can see the sediment, and the reason that makes these plumes, and you can see the colors, is because when a river's flowing really quickly, it can carry all these sediments, but as soon as it hits the ocean, it slows down, and so it doesn't have the energy to carry the sediment anymore, and that's where a delta actually comes from. So far so good. Now this is really cool. I think it's cool because I'm a nerd, but if you look at here, this is the Mississippi watershed, and if I take sorry, Oklahoma, you don't count. Hold that there. So this is the Mississippi watershed. Remember I talked about watershed. That is the land that the water sheds off of into a body of water. And so all of this green land right here, that anything that comes across the land that runs off, that doesn't soak into the ground, is going to eventually end up in the Gulf of Mexico. And so the reason, here's some mountains. So there's the that's right. There's the Appalachians, and here's the Rockies. And so we talk about the Rockies being the continental divide. You know, have you heard that before? Do you know what they actually are dividing? They're not dividing the country in half, are they? They're actually dividing the watershed of the United States between Mexico, the Gulf of Mexico and the Gulf of California. And so over here we have the Colorado River that drains, I'm sure that's not exactly right, but close enough. The Colorado River, everything west of the Rockies drains into the Colorado River and then goes into the Pacific Ocean, the Gulf of Mexico. So what it actually divides the Rockies is dividing the watersheds of the country, which is kind of cool. I don't get out much, so maybe it's not cool, but I think it is. So there's that. So we've dammed it. It's been used for levees, or excuse me, it's been surrounded by levees to make the river deeper, and that's going to prevent flooding from cities like New Orleans. The levees failed during Hurricane Katrina, and that was where all the flooding came from in 2005. Also, gas and oil, when you pull that out, a lot of drilling happens around the Gulf because it's really rich in petroleum. When you drill that out of the ground, you can imagine that kind of leaves a void under the ground, and so the land will settle. When the land settles, it's closer to sea level, and so it's easier to flood it. So there's that. Freshwater. This guy right here, this is super important. All right. So there's just like random sets of numbers that you have to memorize. We already talked about a bunch of them. But we had talked about 40% of the Earth's land, dry surface this is agriculture, 30% forest. Actually, it was like 38% was agriculture. Do you remember these things? Anyway, so we're going 40 on that. But when we look at statistics for water, there's some we have to have memorized. So of all the water on Earth, this 100%, 97.5% is salty, and 2.5% is fresh. So that doesn't leave a whole lot of water for us to drink. Now, the 2.5% that's fresh, this little sliver of this pie here, that guy right there, if we look at that, the AP people also want you to know that 20% of that is in the ground. So of the fresh water, 20% is in the ground, and 79% is frozen. The 79% that's frozen, that's not really potable. And what I mean by that, yeah, it's drinkable as far as like we could drink it if we melted it, but it's not available for our consumption because it's frozen somewhere. So that leaves 1%. So of the 2.5%, we have 1% of that 2.5%. So we're talking about 1% of 2.5%. Move the decimal over one time, right? And so we got like 0.25% of the world's water is actually, oh wait, that would be 10%. So 0.025%. That's crazy. Is like surface fresh water. Most of that's in lakes, about 50% is in lakes. 1% of that 1% of that 2.5% is in rivers. So not very much. Actually, if you look at it, the same amount of water that's in the life on Earth is in the rivers. So it's not very much water in rivers, even though we've dammed them all. 40% is in soil moisture. Who knew that? And then we obviously are going to have some clouds with water vapor and stuff. So, bottom line, 97.5% is salty, 2.5% is fresh. Of the fresh water, about 80% is frozen and 20% is in the ground. Yeah, I know it's 79, I got it. But that 1% that's not frozen or in the ground, most of it's in lakes. Very few amount is in rivers. Okay, so there's your sum. This set of numbers and this set of numbers is really where it's at. Graphs are fun, math is fun. One of your FRQs has math, so this is how we use water. Good times. I put this picture in here because I felt like the book did a terrible job with this. So this is something that I like to talk about and something that you need to understand. What happens, I'm grading your paper, and then you're like, and then the water table gets overdrawn, and then the water in the water table. Like, the water table, water doesn't come from the water table. Water comes from an aquifer. So let me explain it to you. An aquifer is like water in the ground. It's like its little house. So are you always at home? No, but sometimes you can be. And water in the ground, if it's in the ground, if it's at its house, it's an aquifer. So an aquifer is a spongy layer of rock. It can either have like little holes, little pore spaces, or it can have cracks in it. But it has space for water to be. Some rock doesn't have any pore spaces and doesn't have any cracks. And some of that's going to be called impermeable. Im means not, so it's not permeable. Some of that could be like clay. Clay's impermeable, right? Because it has small pore spaces. Or you could have some crystalline rock, which means it's solid like granite. That doesn't have any pore spaces. If you can think about it, if you spill water on your granite countertop, is that going to go anywhere? Maybe eventually, like tiny bit, but not really, right? So anyway, the porous part of the rock that can actually hold water, sandstone's a good example. It has like little spaces. That's called an aquifer. Now, if I look in this aquifer right here, you have this white part. This is called the zone of aeration. And that means that there's air in the pore spaces. So there's part of an aquifer, or there can be part of an aquifer that doesn't actually have water in it. And if you withdraw the aquifer and you remove all the water, then the whole aquifer will be the zone of aeration. You don't have any water in it. So the zone of aeration is the part of the aquifer that's not saturated. The part down here that's blue, guess what that means? It has water in it. Crazy talk. So this is the zone of saturation because the pore spaces are all saturated. And then you can see this line here. There's a line between this white and this blue. So this line between the white and the blue here, if I draw some legs on it, water table. The water table is actually the line between the zone of saturation and the zone of aeration. Okay? So if I'm in an aquifer, the top of where the water is the water table. And so if I have a well or if I have a drought, then the water table is going to go down. Right? But I'm not actually taking water out of the water table. I'm taking water out of the aquifer, and the water table goes down. And you can actually see that right here, this little depression in the water table. And this is called the cone of depression. I'm not making this up. This is, see, that's why I like geology. Like, it's real straightforward. Like, this is my, like, I put this picture in because this is something I know a lot about, but it's called the cone of depression. Okay, like, yeah, it's very straightforward. So I'm actually going to come back to this picture in a little bit when we talk about saltwater intrusion, but there's your introduction. How you feel about that? So here's everything I just told you. I would highlight this. I did want to mention the recharge zone. And on the AP exam, what's going to happen with the recharge zone is, here, let me go back a picture. See all this land up here? This land? That land where water can infiltrate or go back into the ground, that's the recharge zone. If I have a parking lot right here, then water cannot infiltrate right there. So when we talk about cities, it all ties back together, right? On the AP exam, what they're going to expect you to understand is that if I have a city and it's totally covered with parking lots and roads and sidewalks and everything, then I don't get groundwater recharge. I can't recharge the aquifer because everything's covered in a non-porous surface. And so that's the importance of like green spaces and parks and stuff in a city, because you can recharge the aquifer. If you don't have any green spaces, then what's going to happen is all the water is actually going to go into a storm drain, and then it's going to get treated by a sewage treatment plant. So that costs the city money, and then it depletes the aquifer. So the recharge zone, really important. It's just, it's why you need green spaces in cities. And little things like that, like your book doesn't mention, but I just have that backhand knowledge of sitting at a table 8 hours a day for 8 days seeing stuff like this, where it's like, what, really? And so, anyway. So, I think in Genesis chapter, like, 27, I think it was like, and God wanted some Doritos. I think, is that part of the, no? Okay. Well, if God did want some Doritos, like, he made the United States just perfect for us. And I'm making a joke, but in May, when we're reviewing for the AP exam, I'll be like, and this is why the Ogallala aquifer's there. And you can be fancy, called the Ogallala aquifer, but I'm not fancy like that. So if we look at the Midwest of the United States, this is where we have that grass biome. And the reason the grassland biome has the awesome soil is because it doesn't have a lot of rainfall. Remember, rainfall causes leaching in the soil and then everything washes out. So we have this huge egg horizon and a lot of topsoil. And so we have the best soil ever, and then we have literally the world's largest aquifer up underneath it. So if God did want some Doritos, like, you would need awesome soil, and then you would need water. But you can't have awesome soil and a lot of water in the same place. That doesn't work, right? The rainforest has crappy soil. So if you just happen to put the biggest aquifer in the whole world up under the best soil in the whole world, then you can make a lot of Doritos. So we're really, we have it good as far as agriculture goes. And this is why this whole area is not just the soil, we also have the water to irrigate our crops. And so this is why we can subsidize the crap out of corn and sell it and make corn syrup and drive our cars around on corn juice and drink corn juice mixed with acid in aluminum cans, and it's all okay because we have a giant aquifer underneath the best soil ever. It's pretty interesting. I don't really think that God wanted any Doritos, but Doritos are good. Or at least I remember they're good. So let's just all take a moment of silence for Doritos. Okay. The ranch ones, though. Like, what are those little blue flakes on ranch Doritos? What is that? Do you know what I'm talking about? Or
Yeah.
Doritos.
I don't know.
The corn ones are the best.
Cool Ranch. They got some new kinds. My husband will buy them sometimes. I don't support him in that, but you know. Here we go. Again, if you missed it, look at the skills. I actually did that on accident last period, and I was like, okay, I'm going with it. Anyway, so this is a watershed, and so this is what I was telling you. You can see this little white dashed line right here. Like, this would be the Rocky Mountains, and then this over here would be the watershed for the Mississippi. And then this would be the Appalachians, and so there's my Mississippi. A tributary is a smaller river that feeds into a larger river. And this little guy right here that's not marked, that's the mouth of a river, and so that's where it spins out. It spits it out, I guess. That's where I was going. Mouth spits it out. Yeah. Oh, I should totally use that as a teaching thing. That's where a river gets spit out into the ocean, in the mouth. Oh, yeah. Okay. Anyway, just for fun, the top part up here where the water starts is the head. Those are like the headlands for the river. So, anyway, headwaters, I think it's what it's called. Actually, I know that's what it's called, but about that though. Did a better job getting it there. All right, so another thing, I mean, you probably know this, but a runoff is just water that doesn't infiltrate. And so runoff is the water that actually makes it into a river. So if water infiltrates, it ends up in an aquifer. Yes, this is very complicated things. This is super hard, right? No? Okay. All right, there's that. And, oh, I don't know. Okay, watershed. Do you get what a watershed is now? Okay. You don't need to know this. A floodplain, yeah, you know what a floodplain is. Riparian, alright, I think I talked to y'all about this earlier in the year. But have you ever been on like a little adventure, like a fishing trip where you go on camp or whatever, and you're like, I'm going to go down to the river. And then it's always like some crazy bank. And then there's always like these poor little helpless plants. And you just grab a hold of those things and you just hold on. And you know you're going to bust your butt and get your pants dirty. And you just do it anyway. And you're like holding on for dear life so you don't fall in the river. And you end up ripping up every plant on the way down. Have you done that before? Yeah. If you haven't, then you haven't. Can you imagine it? If we went down, you went to the Etowah with me. On the way down that hill, did you not hold on to some helpless vegetation?
Name that hole.
Okay. Well, okay, fine. But if Madeline wasn't there, you'd probably grab a hold of some plants, right? So the riparian part of a stream or a river, the riparian ecosystem, is that part on the stream bank where you rip up the plant so you don't bust your butt. Yeah, I made that up. Okay. So stream or river bank. And so this is that place like right along the edge where you rip up vegetation. And this is a really vegetation. Words over about like 4 letters, can't spell while I'm talking. Not happening. But this is a really important ecosystem because it has a lot of niches, and the reason it has a lot of niches is because you have a great deal of variance in your moisture level, temperature level, and there's different kinds of vegetation along the stream bank. Also, on the AP exam, they'll be like, which of the following would increase turbidity in a river? And then it'll be like, removal of vegetation from the riparian zone. That just means they cut the trees off of the stream bank. And so, of course, that would lead to turbidity because the sediments are going to wash out because you don't have any plant roots holding it. I feel that. Also, it could lead to thermal pollution because you don't have the shade anymore. They should let me write the AP exam because I'd just be like, which one of these makes the water? No, I guess they won't let me write it, will they? Anyway, moving on. Oh, this thing. These guys. Was this hard for you? I'm about to make your life complete. I got a little story for you. So when I was a kid, we were poor, and all we did for vacation was we would go camping, and we would go to Lake Altoona because I live kind of close to Altoona. And you know, you go camping, and you get, if you're lucky, you can get a campsite on the in like a, what's it called? A cove? That's not the word I'm looking for. No, yeah, but like a, I guess.
No, it's a cove.
Okay, that's the word. I don't know why I think of that. Okay, you get the campsite on the cove, and you're like, yeah. And then there's always like that one white trash man in a lawn chair, and like it's too hot outside, so he doesn't like sit on the river bank. He doesn't sit in the riparian zone. Like he just takes his lawn chair and gets up in the river where the little, not river, in the lake where the little plants are. Have you ever seen somebody sit in the lake in a lawn chair? They usually got a beer, like Mossy Oak Cat, right? And then like a fishing pole, and they're just, and the lawn chair has to be a little bit broken in some way. You've seen this before. Okay, so anyway, if we go ahead, if this is Lake Altoona, look at this biodiversity in Lake Altoona. Even though it has an advisory for like every fish, right? Is that what we found out? Okay. So let me draw a little man. There's our lawn chair. One of the legs is broken. It's that one. And here's his little head. And there's his mossy oak cap. It didn't come out right. And so he's got a little fishing pole. He's asleep. And there's his beverage. And he's fishing. Y'all seen this? I have a vast knowledge of redneck experiences. I have a lot. Anyway, the littoral zone. You sit, this little man right here. You sit in the lift. You sit in the littoral zone. So you sit in the lift, and so what I mean by that, the shallow part of a lake where there's like little vegetation and it's shallow enough that you can stand there or sit there in a chair and not drown. And go fishing, that's the littoral zone. It's this shallow part of a lake that kind of brings the body of water. And so he's sitting there in the littoral zone. You sit in the lift. Now, if he gets up a little bit of motivation and he gets his John boat, not like a legit boat, but like a John boat, maybe got a trolling motor, maybe it's broken. But if he gets up in his John boat, do you know what I'm talking about when I say John boat? It's like the kind they sell at Walmart with the, you know, those kind. Yeah, they're like a plastic. You just throw them on the back of your truck or on the top of your car, whatever. Judgment-free zone. Anyway, if he gets up in his John boat, there he is. He lost his fishing pole when he fell asleep, okay? It's all getting recorded. He's awake now. He left his beverage over here too. You don't want to get stopped by the game warden. And he's like, well, I don't know where my fishing pole went. And he found a little net. And he goes fishing with the net. He's like, here, fishy, fishy, fishy. And he says it just like that. Yeah. Are y'all feeling me? So if you get in your John boat and you can go fishing with a net, you're in open water, and that's the limnetic zone. So the limnetic zone is the part of the water where you could actually get in a boat. You gotta be, can't get grounded in the boat, so you have to be out in open water. And it's shallow enough though that you can dip your net over the side, and get you a little fish, or maybe. You can't catch a fish with a net because it's like that whole refraction of light thing. I don't have time to teach you physics right now, but you're always like, oh, I got it. No, you don't. So anyway, that's the limnetic zone, and both of these zones are photic. And so what I mean by that is they're both shallow enough that they have sunlight. So these are both photic. The limnetic zone is photic, and the littoral zone is photic. Or photic. That fancy lady on the video, she said photic, didn't she? I was. So there's that. Now, if you're below the photic zone and you don't have any light, have you ever heard anybody say, oh, that's so profound and that's like a deep thought? Yeah, so the deep water where there's no sunlight, no light, because it's deep, like a deep thought, deep part of the water, like profound, is profundal zone. No light. So profound equals deep, and so we're in the profundal zone. So there's that. Now, the bottom of the lake. Now, it doesn't matter if it's the shallow part. It doesn't matter if you're in the profundal zone. The bottom of anything, anywhere, any depth, is the benthic zone. So benthic equals bottom. And that's easy to remember because they both start with a B. Now, if I was in the bottom of the ocean, that would be the abyssal plane, the abyssal zone. But, that's fine. It's still benthic, technically. That looks like a hot mess. How you feeling? Got all those words now? Think you'll forget that? Nope. Okay. Ugly eye. Do you want me to explain any of those again? Alright, moving on. Hit the lights where everybody falls asleep. Thank you. I just explained all this. You need to know all those words, so feel free to highlight them. I'm not going to do that because I just kind of did. So oligotrophic and eutrophic lakes, we just did an activity on that. The thing about oligotrophic lakes is they have high oxygen and low nutrients. They're sort of the end point for aquatic succession. So over time, like Lake Altoona, if we leave it alone, it doesn't have a bunch of nutrients. It will turn clear and pretty and whatever. We don't have any oligotrophic lakes in Georgia because they're all artificial. So they're all kind of new. Anyway, eutrophic zones or lakes have high nutrients and low oxygen. Ooh, this is always on the AP exam. Let me just tell you about this. So somewhere in Siberia, not even kidding, there's a lake so big that it contains 20% of the surface water, the fresh water on the surface is in Lake Baikal. Did you know that? It's so big they have their own special kind of seals. Would you like to see a Lake Baikal seal? I know, right?
So it's not frozen.
It is not frozen. I'll show you all the things. It is the deepest lake on Earth, and it is the largest by volume of water. That is one of the 100. It's like not the Grand Canyon. It's like Yellowstone. It's the first national park. This is the biggest lake. And they'll have like Lake Michigan, or no, they'll think smart and they'll be like Lake Superior, because that's the biggest, Great Lake. But then that's so super wrong. I had it. Oh yeah, you have a math question on your free response. So they have seals and stuff. Look, it's pretty, right? I think it's pretty. It's in Russian. I still don't even. Yeah, there's a seal. Endemic. What kind of fish we got here? Hang on, let me move this. This is cool. That's a cool looking fish. History. Has a long history of human habitation. These guys used to live there. Okay, not on the AP exam. Alright, cool. Where's this lake at? I want to see. Where in Siberia are we? Looks like we're pretty close to the Arctic Circle. Or, actually, Arctic Ocean. Yeah, I don't know. Oh, I took the internet away. It's not going to work. Sorry. I unplugged the cord. Anyway, so, see, I messed up. Anyway, there's a seal that lives there. Largest lake on Earth. Volume and depth. Promise. You'll see that again. Can you remember that? Right. There's a species of seal. I'm sure there's more than one. If you're the last seal on Earth, no, I'm just kidding. Yeah, it's quite an attraction, I guess, because he's the last one up. I wonder now, as far as like, is there other species? I don't know. Look it up. Let me know. I'm very interested to find out. Anyway, so now you know something on the AP exam. Deepest and the most volume. And it wasn't until last year that I even mentioned this lake, just because, like, I want to teach you, like, the 90% that they ask every single year, like, eutrophication to hypoxia. That's a big deal. This is, like, random fact crap. And so, I was like, whatever, I don't care. But here you go. There's your answer. May the fives be with you. Okay, so wetlands, they can include swamps and bogs. Swamps have forested areas, bogs don't. That's a swamp because it has trees. A bog would just be like a covered in like a kind of what? Like what? Just wet mud. True. So wetlands are really important, and on the AP exam, what they're going to ask you about for wetlands is they're going to ask you about the ecosystem services. And so wetlands can absorb a lot of water. They kind of act like a sponge like that. And so if you have something like a hurricane, and we're in, Louisiana, we're worried about, the thing about hurricanes, I mean, I know they have really heavy winds. The thing that will really cause extensive damage with hurricanes is the storm surge. This temporary rise of 5-10 feet of sea level, and that's where everything gets really destroyed. And so they help to mitigate the flooding from storm surges, from hurricanes. They help to sort of dampen the winds from that and kind of bear the brunt of the force. And then also, if you have, when we have lakes and rivers and streams, y'all saw this in the movie, right? Those people were testifying in court and they were like, I have a lake in my backyard, I have a river in my backyard, and now it's dry because the nesting went in and they started pulling the water out, right? And so wetlands and lakes and streams and they're all connected to the aquifer. If you think about it, have you ever seen like a giant lake or a river like up on the top of a mountain? You don't have to get to a river, you don't have to hold the vegetation to climb up a hill. Don't you always have to go downhill? So where the aquifer meets the surface, that's where you have a lake, that's where you have a river. And that's for that reason, right? Those things are all tied together, and wetlands are tied together with the aquifer too. And so they're going to recharge the aquifer. And then also a lot of marshy plants can do bioremediation. So there are swamp grasses that can literally clean up pollution, and that's bullcrap if you say it like that. So what you have to say, they can actually take out heavy metals like cadmium from water, and they can pull it up into their stalks and hold on to it, which is kind of cool. So bioremediation and swamp, I guess I should say wetland grasses. Sometimes when you have like wastewater treatment, they'll have artificial wetlands and they'll plant some of these like cat nine tail sort of plants, and that'll help to remove some of the heavy metals, which I think is really cool. It's a good idea, and then it'll recharge the aquifer. Everybody's happy. Moving on. This shows freshwater per capita. Notice that most of the places that have a lot of water, that's the blue and the purple, they don't have a lot of people, or they're on the equator. So here's the equator. It goes above the fat part of Brazil. Wait, I missed it. There's the equator. Okay, so of course, you know, that whole Ecuador, Brazil place has a lot. Australia's pretty dry. They're on 30 degrees south of the equator, but they don't have a lot of people, so they have plenty of water. Of course, Siberia, this 60 degrees north of the equator, it's a route right there. Yeah, they have a lot of water because that's an area that gets a lot of rain. We're going to talk about that. But the desert parts, Middle East, really short on fresh water per capita. And so they use their oil and they kind of can, whatever, I'll just hit don't save changes. So I have the whole world in my hands. No, so most of the rivers are dammed. We use water. Irrigation is the biggest use of water, fresh water. So of course we're using more water to grow our food and clothes. We're using about 70% more water than we did 50 years ago. Thank you, Green Revolution and Mr. Warlog, because we grew more intensive types of wheat, specifically, need more water. So irrigation is very inefficient. We had talked about the different kinds. Flood and furrow, that's just where you take an area, you just flood it with water and you let it soak in, and you're not really targeting anything. And remember, the answer on the AP exam is always drip irrigation, wherever that is. Is that on here? Somewhere it is. In your mind it is. And that's the answer for reducing water use in farming. You know, if you can afford pipes with little holes in them and you don't mind putting that out. But hey, you don't have to answer that, do you? Anyway, so there's a lot of places that the major rivers don't actually reach the ocean. The Colorado River is an example because it's been dammed. I think it has like 20 dams on it. I mean, it's stupid. Maybe up to 30. The RLC is kind of interesting. So let me show you what that ended up happening here. What was going on post like Cold War, Iron Curtain thing, trying to get some economic development going. And so around the area with the RLC, cotton was pretty expensive, and they thought, okay, we're going to divert some water and we're going to grow cotton. It's going to be great. And cotton is extremely heavy on water and pesticide use. And so they ended up causing, this is a dry area. Can you tell this is a dry area? So they ended up causing soil salinization because they had to irrigate it so much, and the evaporation left the salt behind. Remember, Rhonda, it's got what plants craze, it's got electrolytes. Well, when they over-irrigated this dry area to grow cotton, they caused soil salinization. All of the salts were left behind. So they degraded their farming land because they were trying to grow something that didn't actually match with the land. And then also look how much they drained the lake. And this little camel, I can imagine this little camel family on vacation, and it's like, hey, honey, take a picture of me and the kid with the boat. Do you think that's how it happened? I think that's not a good angle to get your picture made from, but what is? Okay, so anyway, this was in Kazakhstan. Is that where? Thanks. Say it one more time. Kazakhstan. I think I've watched. My husband watched that movie with that man that made all those jokes. What's his name? What? You know which one I'm talking about? Completely inappropriate movie. But the guy, he was like, "My name is Bor. Do you know which one I'm talking about? No.
Oh, is that the dictator?
Yeah, no, it was before that. My name is whatever. Anyway, he was from a make-believe country, and it sounded a lot like Kazakhstan, but it wasn't that one. It was a different one. Borat, yeah. So he was from some make-believe country that sounded a lot like Kazakhstan, but it's not that, so I always mess that name. Don't watch that movie. It's awful. I hate my husband for showing it to me. I couldn't. It was like in the background, and I was working, and some things you just can't not see. Anyway, so these red areas are places on Earth where water's getting overdrawn. Hey, let's grow some wheat, and I'll tell you what, let's grow some grapes for wine, and let's feed our 1.3 billion people, and are 1.1 billion people, and we're going to have 70 kids apiece, and that's what's happening. Okay? So there's water use of the world in a nutshell. So what ends up happening when you take water out of aquifers? If you can think about that rock having little holes in it where water can live, if you withdraw the water, I mean, obviously that's not going to be as structurally sound after you get done. So after you withdraw the water, the aquifers are going to subside, and that's going to have a sinkhole. Now, places like Rome are just ate up with sinkholes, and so is where, they built the Newcastle High School. Do you know they had to spend like millions of dollars fixing sinkholes in that area? Did you know that?
I didn't know. I just don't know why they kept building it. Because they said in 10 to 12 years it could just
Fall in?
Yeah.
Sounds super safe. So,
well, they said they got the land cheap.
I wonder why. Do you ever go to like Old Navy or Target and they got the clearance rack? Like, that ain't the pretty stuff on the clearance rack. There's a reason somebody didn't already buy that. Alright, so anyway, that can cause sinkholes, and the limestone is what's up under northern Bartow County and like Florida County, where Berry College has a lot of sinkholes, for example. And so that rock it's porous, and it has like little tiny caves and stuff, and sometimes it has bigger caves, but it's gonna fall in when that happens. So here's some examples. That picture isn't sideways, the ground is sideways, and there's a sinkhole. I watched this video, and there was like a family, and there was a brother and another brother, and they lived together. And like one brother was in his room like watching TV, and then their house fell on the ground. It split the house in half, and then they never found the brother. That really happened. Did you ever hear about that? If we get done early, I'm totally going to find that movie. It was a news story. Did you hear about that?
No.
Like, was it recent?
It was like last year. You remember that? Nick's with me. I know I'm not making it up. But it was in Florida, wasn't it?
Yeah.
Yeah, so Florida has that limestone bedrock too. Anyway, let's see, groundwater, people drink water, okay, cool. Flooding is good. And it brings those nutrient-rich sediments, but they damage property, so people get sad when their house washes away. Levees help, but let's see. The thing about levees is, if you can think about like a giant, really wide river, if you take it and you make that river deeper and more narrow so that it doesn't flood your town, you're going to make that water move a lot faster. So if you do have flooding, it's going to be more devastating. And then also the sediment that should get deposited at the mouth of the river, where the river spits out into the ocean, that sediment's going to be moving really quickly, so it's not going to get deposited there right at the edge of the coast. It's going to get deposited farther out to sea. Okay, so like I said, levees actually can make flooding worse because they make the water go faster, and they prevent that siltation. That's what that's called. When you deposit silt on a riverbank, it's called siltation. So that's when a levee fails. I bet you $1 that's probably from Hurricane Katrina. Okay. I haven't memorized all the pictures from your new book, but I have enough sense to know what's going on. Anyway, we divert water to drink. And so, yep. A dam. I refuse to tell you what that is. The big lake behind the dam is called a reservoir. I will tell you that. So if you want to think about it like that, Lake Altina is actually not a lake, it's a reservoir. And so behind the Hoover Dam, for example, big famous reservoir is called Lake Mead. Yes, heard that before. So I wonder what the reservoir behind the Three Gorges Dam is called. I want to know what that lake's called. I don't know. Do you know? Okay, we'll look that up when we look up the where that fell in the hole. Okay? Make a list. A few major rivers remain undammed in remote parts of Canada, Alaska, and Russia. They don't give a damn. So they don't need any. They don't need any dams because I have plenty of drinking water. You know I don't cuss right. Like, this is as close as I cuss. My husband would divorce me if I said a dirty word. I have never heard that man. I've been with him for like a long time. 14 years. He's never said a bad word. You're a better person than me. Like, why haven't you left me yet? Because I'm not being nice sometimes. Alright, so let's look at the positives and the negatives of dams. Alright, so positives. They give you reliable drinking water if the watershed is of good quality. So that's a positive social cost, and that could be a positive economic cost. because you could bottle the water and sell it. Reliable irrigation for farming. So that's going to be a positive economic thing. So carbon emissions are going to be lower. They're technically not lower, and I'll get to that like in the energy unit. So, but you don't have to burn fossil fuels to make energy, which means that you don't have to mine, which causes less habitat fragmentation and biodiversity loss. Do you see how you have to make like this long line of like things that normal people wouldn't say? That's how you have to do on the AP exam. So the energy is renewable because water, as long as it's there, can be used to turn the turbines. You're going to control floods, and so that's going to be a positive social cost because less lives are lost. It's going to be positive economically in the fact that property won't be damaged. You can make new recreational opportunities in the lake that you make. As long as you don't think about like what was underneath there. Okay, negatives. People have to move 40 to 80 million people in the last 50 years. That's a lot. A lot of that's from the Three Gorges Dam, and a lot of that's from loans from the World Bank because they like to fund dams. Okay. So sediment, a bad thing. Sediment settles behind the dams, so that sediment that should be recharging agricultural lands, that should be recharging the wetlands, and should be depositing the silt there. What ends up happening with that sediment is if you block the flow of the river, the sediment actually settles behind the dam, behind in the reservoir. It doesn't ever make it to the ocean. It doesn't ever make it to Farmer John. Okay, so you do have a small risk of catastrophic failure. That seems like such an oxymoron. There's a small risk of catastrophic failure. So anyway, habitat alteration. So if you're like a trout and you live in the water, and then it turns into a lake. Like there's such a thing as a lake trout, but it's a different species as like of a rainbow trout that lives in rivers. You see, so it's a different niche. Lots of recreational opportunities like fishing for trout or kayaking or whatever. This guy is so close to the dam, right? Yeah,
He's as big as the first lake.
and what's this? What happened here
Oh, they made it for understanding.
with his?
Giant self.
That's a red donut. That's what? It's a red donut.
It looks like a lady
farm silo.
That is hilarious. Okay, maybe it's just our perspective.
Yeah, he's giant compared to that boat.
Yeah.
And the house.
The boat?
Oh, I got it. He's the Michelin Man, right? Because he's got a tire. Ha. Okay, anyway, fisheries are going to decline because what's going to end up happening? Two things. They're not going to be able to get upstream to whatever that's called where fish do that thing. Spawn. That's it. So you know what I'm talking about when I say fish spawns? Fish lay their eggs and then the other fish come along and lay their seed. That's the nicest way I can say that. Anyway, also, sorry. The water at the bottom of the reservoir, like behind this wall. Think about the water way deep, like 100 foot deep in the reservoir. What temperature is that? Super cold, dude. If he needs a wetsuit if he's about to get in there. And this water is going to run down through the dam, come out the, go through the turbines, all that. And it's going to come out, and this river is probably pretty warm because it's just surface water. And so if you're a fish or an amphibian and you're cold-blooded, you're going to be subjected to colder temperatures beyond your range of tolerance, and you're going to die. So anyway, and last one, the flooding that builds up topsoil is going to be stopped by it's called sedimentation when it deposits behind the reservoir. So, all your dirt is up under the water, and it doesn't go downstream. So, there's dams in a nutshell. That's pretty straightforward. All right, so there's a bunch of dams. They are expensive. There's a picture of dams. Those are those people, right? Where's that guy carrying his furniture on his back? Do you remember that?
Yeah.
Had a chifforobe. Is that a word? Good deal. Did your parents say that word before, chifforobe? It's like he had his closet on his back. Okay, let's just go with that. Dams. Some people want to remove them. Okay, desalination. You can also call it desalination. I'm going to go with desalination. Same thing. I'm just desalting that water, okay? Remember saline eye drops? That means maybe your tears were salty. Okay. So if I want to have some fresh drinking water, you can't drink salt water. That doesn't work out for you. And so what you have to do, there's two different ways you can go about this. The first one is distilling water. And distilled water just means it's been boiled. And so have you ever heard of, like, if you want to go make some moonshine, you got to make the mash out of the corn and the water. The mash is like this. Okay. I'm a redneck, okay? It's where you have to take it and kind of mash up the corn and the water, and it starts to ferment. Have you not seen that show on the TV? What did you say? Okay. So anyway, when your uncle makes moonshine, he has the mash, and what you have to do is you have to heat up the mash. And a whiskey still. Have you heard of a moonshine still or a whiskey still? All right. What they're doing there is they're distilling the alcohol, and alcohol will boil at a pretty low temperature. And so if you heat up the mash, the alcohol will actually evaporate, and then you can collect it all. And then left in the pot, the gross stuff, is water, and water boils at a higher temperature. So they're doing some pretty involved chemistry to separate things out by boiling point. But a whiskey still comes from the word distillation, which is separation by boiling. And so if we have salt water and we'd like to have not salt water anymore, what you do is distillation. And so you just boil the water and then you trap off the clean water. There's a couple different ways to go about that. And it leaves the salt behind. And so places like Saudi Arabia, for example, they have tons of oil and they don't have any clean water, or excuse me, fresh water, I should say. And so on the AP exam, huge thing, pet peeve of the people sitting there grading the papers, right? Fresh water and clean water are not the same. Fresh water means it doesn't have salt in it. Clean water means it is not polluted, okay? So fresh water means not salty. So keep that straight, because if you start talking about, the kind of guy, I had to not give points. You don't take off points. You can't write on the paper, you'll get fired. But like you're giving points, and some people were talking about water coming into the Okefenokee swamp and all this, and like they had said salt water instead of fresh water. I couldn't give them credit. It was crazy. Anyway, so keep that straight. Also, you can do reverse osmosis. So osmosis in biology is where a passive sort of transfer, where water goes from an area of high concentration to an area of low concentration. So if I have salty water and fresh water, they'll both end up kind of salty. Is that biology? Is that kicking in your brain? Reverse osmosis is where you push it through the filter the wrong way, and that is active. It's not a passive thing. So you have to put electricity into it. So when you buy Dasani, like what you're buying is water filtered through reverse osmosis. That means they use electricity to take tap water, which was already totally potable, drinkable, and they force it through the filter the wrong way, and then they put salt back in it to make it taste right. And then that bottle, who has a plastic bottle? No, like you got one. Give me a bottle. Alright, so, yeah, this is purified drinking water. Let's see how they purified it. I bet they didn't come out of pocket to do reverse osmosis. At least Coca-Cola will. Yeah.
I'm sure, I think mine says reverse osmosis.
What kind you got? Dasani
water.
Oh, okay. Dasani is like a city of Atlanta tap water. Did you know that? Is that really what she was wanting? Is that really what it says? Reverse osmosis. Okay, so this is tap water, and they put it through a filter the wrong way. And it has electrolytes, and it has a battery inside it. It's all the energy that you need. You realize that salt has no calories, right? What? What? Oh, it's got, yeah. But if I look at this Niagara bottle here, and it is, come on, pure, oh, it says it, reverse osmosis. And then the ingredient, does it have salt in there? Ingredients. Usually they have like magnesium carbonate or something like that. You know what I'm talking about? That's salt. They just put it back in there to give it a taste. So they filter it, they filter drinking water, use the energy to do that. Oh, and this, if you fill it up about a third, not this much, if you fill it up a third of the way with oil, that's how much oil it takes to make this bottle. And it has BPA, which is an endocrine disruptor. Is this really what you wanted? Is that really where you're going with that? No, don't do it. Don't do it. It's not worth it. Alright, so there's a bunch of desalination facilities, super expensive. It takes a huge amount of oil or any kind of fossil fuel to heat up the water, because you have to boil water, right? That takes a lot of energy. And so you have all the salty water waste. And so if we look at who does that, Saudi Arabia wins. They don't really have that many people, but they don't have any water because they're in the desert. But they have oil, so whatever. They cook their salt water with oil. It's fine. We have the facilities to do it, but we don't do it because it's expensive. Japan does quite a bit for their little island. They're the size of California, but they have like a third of our population. So yeah, they got to cook some water down. They don't have any. Here's where I was talking about drip irrigation that wins, and then plant stuff that matches the land and the climate. Sometimes that works. Oh, it's this there. And so don't plant cotton in the middle of Kazakhstan. That's not a good idea. So I'll show you this little picture. I mean, I think if the AP exam said, how can you in your house conserve water? Yeah, you wish they asked you that. You wish. They're not going to. But if they did, you could totally say dual flush toilets, low flow faucets. I mean, is that something that you're aware of that exists? Yeah, okay. Another one, this is more like what they're going to ask you, xeriscaping. And so let me show you what that looks like. Do you remember on the top of that building, the apartment building, they had these little succulent plants? And this guy was like, I don't even know how to say this. It's got 40 letters. And then you didn't know what he was talking about. And it had the little juicy leaves. A succulent plant is like a juicy plant. It holds water in its leaves, like aloe is a succulent. Like you have I don't know, a steak, you're like, this is such succulent meat. Like that, you're just being it's juicy, okay? So these are juicy plants. So fancy, okay? And so these little guys can hold water in their leaves, and so this is called xeriscaping. And xeriscaping is just a type of landscaping where you plant outside your house or residence. You plant things that don't require a lot of water. That was a lot of talking to explain that word. I don't care. Yeah. So it is in chapter 15 of your textbook that they define the word pollution. I'm not kidding. There it is. Point sources and non-point sources. These are really important. So go ahead and highlight this. Point sources are addressed in the Clean Water Act, and non-point are not addressed. Okay, that wasn't really what I wanted. These are not addressed. So the largest major source of water pollution in the United States is not addressed in the Clean Water Act. The Clean Water Act is in charge of stuff like the discharge from a factory, the discharge from a wastewater treatment plant, these large producers of pollution. The Clean Water Act doesn't have anything to do with you spraying Roundup on your yard, fertilizing your yard. I mean, people change their oil in their driveway and it goes into the river, whatever. Like, it's not going to come in. Nobody's going to arrest you for doing that. Can you imagine? That's not a thing. We don't have the people to do that. So I'm going to show you this one little slide. I'm going to call it a day. All right, look. This comes back over and over again. It comes back with air pollution. Point source. Take a finger. Okay, pick this finger. Pick the right finger. This one. If you can take on your paper and you can point with one finger, to where pollution is coming from, then that's a point source. I cannot point with one finger to all the farms in Nebraska. They don't have that many fingers. I cannot point to a giant area of national forest that has been logged. That is not a point source. That's non-point. Okay. So point sources include animal feedlots. So I'm going to put a P for point. So see, I can point to a discharge pipe on a factory. I can point to water that was used for cooling at Plant Bow, and I can point to that. I can point to this pipe. I can point to this oil spill with one finger. I can point to all those things. Non-point, I cannot point with one finger to a giant 18-hole golf course. I can't point to that. A giant farm, a whole subdivision, a giant construction site, or an area that's been deforested. An abandoned mine, if it's a huge open pit mine over several acres, that's non-point. If you have one pile of mine tailings, that would be point. Bye! That is where I was going to stop for the day. Does that make you feel better? No? Sorry.
Corey Staten, please come to guidance. Corey Staten, please come to guidance.
Oh, we didn't get to look up, what was that we were going to look up? Oh, the guy that fell in the hole. And something else. I don't remember.